Okay, today's repair we have in, this is not ours, it belongs to someone, and they asked if we take a look at it. I'd say it's a late 70s, mid to late 70s AM/FM radio with a clock, alarm, and this high intensity lamp here, which is just a 12 volt 93 bulb. So he says the radio and the lamp isn't working. The radio and the lamp isn't working, but the clock works. And I'll demonstrate here with some AC. You can see the clock is turning. But if we turn the light low, medium, high, it doesn't do anything. And these knobs are kind of loose, so we're going to have to go and take a look at that. And I'm assuming just something is broken off the switch. There is a schematic diagram, the miniature. Gives you some focus here. Okay, over here on the right hand side is where your AC comes in, and you can see why the clock works in the bottom right is because the AC motor is wired across the primary of the transformer. And the low, medium, and high just takes of the bulb. It just takes different taps off the AC, and there's your audio output here and whatnot. But let's open this up and see if we can find the defect. Okay, right off the bat, I'm looking at the switch, and the switch looks okay. I've just checked. I was hoping that because of the switch being loose, that there was some in the pot there'd be some broken wiring or something, but it doesn't appear to be that. I'm wondering if the transformer itself now is open, because there's a lot of taps in there, and although we have the schematic, it doesn't detail which color is which. I would have to take a guess at the center taps and whatnot. But let's start with the primary. The clock is running, so we know the primary is getting its power. Okay, orange, yellow, brown, and blue here, and black, which goes to one side of the lamp. So these wires here have to have, between the black and these, have to have some taps. I do also notice the two AC blue leads here, which go to the rectifier there, and that's not a bridge, that's just one diode, so half-wave rectification, some filtering. We'll see if there's any AC at these two blue terminals right there, and it looks like it also has a black center tap here also. That's the same black. Okay, there's no AC coming out of this transformer. I've checked with the meter. The clock is running, so we know there's nothing wrong with the AC input here, although it does look a bit green and corroded or whatnot. But the clock's working, and this is fine. So we're going to have to take a look at this transformer, hoping there's one of those thermo fuses just inside the primary. Okay, the transformer's removed, and there is no, I pulled this one wire out of here to just check. Came out quite easily. There's this primary is open, and I don't quite understand the two blues here. I would assume is AC, but the schematic doesn't show, unless there's a lamp up in the clock or something, and the schematic doesn't show what these two blue wires do here. It just shows the motor for the clock. It doesn't show, unless I'll look closer, where this these blue wires here are about. But our primary is open. Okay, looking at the schematic, although it makes more sense, this is a clock radio, so that most likely is the switch to turn the radio on automatically via the clock. So let's take a look at this transformer. Okay, I've simply just pried up these ears tabs here. I want to get these bells off this transformer. So without too much fuss here, this will lift right off, and we'll expose the windings now. This is not a guarantee that we'll be able to get this. It's hard to do one-handed, but I just want to lift this off. like so. I could mark which side that was, although I don't think it matters. Let's go over that side. And we're concerned with the primary. Those fuse devices are always on the primary side. Let me get in here and just pry that. I just took an X-Acto knife blade and just went down the sides here to get that caked on coating off. It's usually just taped right under this little section here. It does look like it's gotten a little toasty over time. So I want to be careful. I want to get right in here. I may do just one little slice there and carefully look inside on one of these. Sometimes it's tucked over here. This is where it gets dicey. Yes, this transformer did get kind of warm here. You can see there's some melting there and some melting there due to overheating. Now these were made to run on 117 according to the decal, and I'm curious if today's higher line voltage has anything to do with that. We run typically over 120, close to 125 here. Well, as we dig deeper into this carefully, it's not looking good. This has to be before they use those thermal devices. And I'm thinking this is pretty burnt up, not knowing anything about it. What these secondaries are, it's going to be near impossible to find a replacement. Again, I wish I knew Japanese transformer color codes, as red's obviously the primary. I'm guessing by the filter capacitors here, it's 16 volts, the two 500s, one rectifier. I'm having a little trouble reading. Let me get you some focus here. Okay, I can't get you much focus on this diagram here, but I'll have this blown up. There's our power transformer. I'm guessing it's a 12 volt center tapped. The bulb runs on 12 volts. And the radio runs on, I'd say, about 6 rectified 8 volts. And that's half the value for that capacitor, voltage wise. So we're going to try feeding in some we could try feeding the radio some voltage in the lamp. Maybe we could take a transformer out of something close and worry about the lamp later. Yeah, I believe our luck has run out with this transformer, because as we looked a little further, here's our other winding of the primary that went in that hole right there, and that's in the center of the transformer. You can see the melted path. The other one is still connected okay. There's just no way. There's just no way to get that. We're going to have to try to find some suitable replacement here to tack in here. And the light, haven't figured that one out yet. So I'm confident I could make that radio work if I could only. The one on the left goes up to the diode there. Actually, it's hard even for me to see, but basically the two taps, these are numbered 1, 2, 3, 4, 5, 6, 7, and it's using one of the middle taps there and the one on the very leftmost. So it's numbered 1, 2 for the primary, then 3, 4, 5 from right to left, 6, 7. So what I'm saying is, looks like it's confused by the discriminator there. The basically a 6 or an 8 volt transformer or a 12 volt center tap. We could probably have the light come on full and run the radio but we wouldn't have the selectable low, medium, high for the lamp. So we'll just I'm gonna just button this back up for now. Go on ahead and put everything back. I may want to power it up with some AC just to see. Meter out which one of these leads is which. 1, 2, 3, 4, 5, 6, 7. Maybe they follow the color code. 1, 2, and this is 3, 4, 5. Orange could be 3. I don't know. We'll just have to meter that out. I'm going to have to blow this diagram up so you can see it, but basically our transformer there has the main secondary, has 1, 2 taps. So what it is on the leftmost is one side of the AC power. The second one from the left is low for the lamp. The middle is medium, which runs the radio and medium. Oh wait, I missed that second one there. That one runs medium. And then I believe the third one, the fourth one, runs the radio and medium. And then high is the rightmost. So basically, low, medium, high. Low, medium, high. I'll revisit this, but that's what I'm thinking is. And it's a negative ground. It's that silly negative ground. So we're going to just feed this like 6 or 9 volts and just see what happens. And take another closer look at that diagram of the transformer there. Goes up to the switch and it shows you by the lines which functions it does together. The one with the motor is the wake to music or turn the radio on switch, and the other switch has 3 wafers or 3 sections it looks like, or anyway has 3 sets of lines to tell you low, medium, high, and the lamp is common to the transformer. So we'll know what that one is, and then we just go to the radio runs off of, I'll look again, but the radio runs off of one of those middle ones there, and is also medium on the lamp. That's this switch here. Okay, I'll correct myself. Counting from the left, that's the common, we'll call it. It goes straight up to the lamp. The first one is low, the first tap is low. I believe the second is medium, or the third is medium, but one of those two runs the radio, and then the end of the winding is high. So it's the common, low, medium, the radio, and high, or the radio and medium. But those two in the middle and medium make sense. If the lamp is 12 volts, 1 amp, and these two are right around medium, which would be, I would say, 6 volts, then this radio runs on that center. That tap is for, that's for 6 volts. So it's a 12 volt, I would say a 606 transformer, which makes it a 12, and it has some other taps to light the lamp, but it is cooked and we need to replace it with something. Let's try the radio. Let's try feeding the radio some AC. The hardest thing here is reading this crazy switch because I don't know how it's numbered. And all the secondaries are connected of the transformer, so it's hard to get a reading of which wire is really which wire as far as the secondary goes, unless I disconnect each one of these, which I don't know how much time I want to spend on this. But basically over here, the blue wires at this end of the board, the blue wires are the switch for the clock. This green wire and the black wire over here, that's what's common to the lamp. And the green wire goes to the center pad here, which goes up to the switch. So the switch turns on, and I believe the power now will be at the two extremes of the board, where this is just a coupling point for the switch and the green wire off of this switch. Why they have it going up there, I have no idea. Well, any event, that's only the lamp switch. Has nothing to do with the radio. And there's our rectifier. So I'll try and put a little bit of AC on each side of this here, or here with the switch on, or it doesn't matter. And I have a little experimenting kit here, but this puts out like 18 and 18. We can't use this, but this is basically what's going on, is except these windings are tied together, and there's different taps for everything. But we have no transformer like that, so we have to come up with something. Maybe put an LED lamp in the lamp, a car LED in the lamp, and just run it. I don't know yet. We'll worry about the radio first. Okay, I've gone ahead and disconnected the green wire here, and I've marked it with some colored marker. Typically I would cut it and leave some of the green insulation on there so I know where that wire went. As if I was going to cut the yellow one, I would snip it off and leave a tail of the yellow on there so I knew, but I just marked it with the Sharpie. I don't have a source of AC readily available, so I was thinking there's no reason why I can't just put DC. This is the diode anyway, so I'm going to put DC in. I'm going to go from the lamp, the side common of the lamp, and I'm going to hit with the switch on or off, doesn't matter. I think I'm going to put it on the without the switch right on that corner by the diode. So I've got the power supply dialed up to 6 volts. I had to disconnect the green wire because I'm across the secondary of that transformer, and I was watching my current limiting and it was going up over an amp. I'm like, that's not right, and it's because I'm going across the winding of that transformer, I'm guessing. So let's give this a try over here. This radio should come on. Okay, I don't quite understand this. I have the lamp on. The lamp is turned off, so it's backfeeding somehow, but I do have radio. I'm drawing 0.86 amps. I should take that lamp off. I don't know why the lamp is coming on though. Maybe that wire is touching something over here. Jeekers crow, get out of there. Now we have just radio. Let me attach this so it stays permanent. A bizarro thing, I'm just touching the soldering iron here to add this wire, and the radio plays. Just by touching the iron, so it's picking up the leakage from the iron, and that's something.
You tweeted out a few days ago, Santa got me a boot for Christmas, a nice picture of your Range Rover with a giant yellow boot.
That's wide open.
For, parking violations, I would assume. Is the
8 volts. I had it up at 10. 10 or 12. It started humming a little, so I don't want to. I don't think it runs on 12. I think it runs on like. It won't run on 6. It only comes to life about 8.
That parking in Boston isn't. The city of Boston is no joke, and the city of Boston always wins in the end when you're in a parking war with them. How much money did it take you extricate the boot from your Range Rover?
I'm not going to go into.
Seems to like 9. So 6 volts rectified. It was somewhere in that range.
That sounds like coal in your stocking a little bit, Riley.
And varying the lamp switch does cause some issue. Try AM. Volume is scratchy.
You need to build General Steel today before you spend thousands more than you should. General Steel pre-engineered buildings could save you as much as half the cost.
Alright, so don't know where we're going to take this, or... what we're going to do here, but it's where we are for now with this thing.
Like, hold on, baby girl, like, come here. Like, this woman right here, she came out gorgeous tonight. Right. And was not trying to dance. She was not trying to dance. Not trying to Nothing wrong with
So I don't know what to do with this.
I'm not sure what my mouth do, but I'll show you what my fists do.
Yeah, what does your mouth do, Laura?
Oh, mine talks.
Should we get into... Okay.
And, yeah.
We'll talk about that.
So what I'd like to do is, maybe I'll just attach it to a wall wart or something and say, look, this is all we can do for now, and at least your radio works.
So in the middle of
The
that
lamp,
interview, this guy breaks
could either put on another wall wart or something. I don't know what I want to do with this yet, but I know the wiring in here is crazy. I tightened up these loose knobs. We need to spray the controls. We'll do that. The AM/FM switch is mounted right here to the control panel under here where you can't get to the screws to take it out. I don't want to touch it because all the wires are underneath the dial, and I've been here in the 70s and 80s. You just don't want to go in this stuff. The AM/FM wiring for the switch is scattered all over points of the opposite side of the board, just tacked all over. It's a nightmare under there.
Talk to you because you're rude and you're a so up. Nobody even likes the Yankees. You're in Boston, so stroll away.
Have you met this guy before?
He tried to dance with my friend, but she wasn't interested.
There's the AM/FM switch I'm talking about. It's hard to see, but you have all those connections on that switch, and then they stop, and it's mounted to the plastic, which is not part of the circuit board here, and all those wires are just tacked. Oh, there's dial string in there, and about a dozen of these AM/FM switch wires just littered all over the underside of this board. It's just a mess in there. It's our bad transformer. I don't know what I'm going to do with this for a final. I'll try and find maybe a transformer that'll work and just tack it up and worry. Maybe a wall wart for the light, maybe. Well, I was looking for an AC source to run the radio to try 6 volts versus the 9 or 12. I want to try AC. We stumbled upon old 64 Goats, one of his test transformers here. This is probably more for a tube unit. It has 500 volt center tap secondaries there, which are safely taped off. But green is 6.3 for the filament, so we got 6.3 volts. We fed that into the radio, so it can be rectified by the radio.
Inside of.
And it works fine. So
And it would
this is the antenna here.
successful.
So my suspicions are confirmed that there was a 12 volt secondary with a 6 volt center to run the radio and the lamp, one close by to run the lamp. So I still don't know what we're going to do about this, but
Fierce criticism from the deal, as well as
it seems to run pretty well on 6 volts.
Now and save up to $6,000 on any new or pre-owned Mazda in stock.
North End.
Maybe run on 9 volts, but it seems,
I would pick on a playoff team. Exactly. They've never won a playoff game with Andy Dalton. He
I think 6 will be okay for
numbers.
this.
He actually got himself a pretty fat contract.
To do with the millions of illegal immigrants already here.
I touched up the volume control.
Democrat, they say the border, control the flow of immigration, or illegal. Just remember, there's no
So we'll come
undocumented
up with
workers.
some sort of
I'm calling
workaround.
myself one today. But I think that's a euphemism that you much as I do.
Find something that may fit in there.
Have an opportunity here next
Multi-tap
week when
secondary
they
replacement
meet developers
transformer?
on
I
January
don't know
6th.
yet.
Have an opportunity.
Just a little further testing here on 6 volts. That speaker sounded blown, like there's either a fur ball in it or things have gotten in behind or it's just blown, so I've substituted it. And it sounds a lot better.
Right now at 18.16, the NASDAQ is ahead by 12.
From the WH Radio Newsroom in Boston, I'm Jordan Weinstein, in for Bob C. Tonight, the city of Boston will welcome the new year with record sales this past weekend. General Motors and the Diamond GM dealership and
The Nazarene.
And Jesus answered, I told you that I am he. If you're looking for me, then let these men go. This happened, we're told, so that the words he had spoken would be fulfilled.
Alright, a little further testing on this. I just wanted to see what this power supply is running at. And I got minus, I got glare there, but minus.
And I hope you're having a great day. This is Paul with St. Paul and the Broken Bones, and you're listening to Carolyn Morrill on Boston's independent radio, The River.
So these are 16 volt caps running at about -7. So that must be what it's about. It still sounds a little raspy to me, but I don't think that diode is weak or anything. It looks like a silicon diode. -7 volts. I think if we got up around 8, it starts to sound better, but that would mean putting like 9 volts into it. Okay, I've attached a 9 volt AC wall wart to it, and I've attached the factory speaker, and I'm getting about 11, almost 12 volts on the power supply. So I think that might be a little high, 11 volts. I think it's designed to run on. I'm going to hook the other speaker back up. Okay. This is a 5 ohm speaker. I don't want to get any copyright things. But I'll try it on 9 volts now with a good sounding speaker. To me it still sounds like it's starving for power a little bit. I'll do a voltage measurement here. About 7 volts. Well, it definitely sounds better, but I don't think it's supposed to be running at 10.6. Maybe. That's with the 9 volt AC transformer. And I moved the wire, of course. Doesn't have that distortion at that 10.5. It just seems to like this 10.5, 11 volts. It seems underpowered at 6. So that's our input voltage, 10.5 out of the 9 volt. I didn't check the DC voltage. So our DC voltage is 10.8. The AC going in . Oh, come on. 10.5 AC going in. If it stays. 10.7 coming out. Okay, so we're just running it with a separate speaker, 9 volt wall wart. It'll run off the sleep timer here in the clock. But the only thing, we're missing the taps for the light. I can't light the light. via the switch. I could probably come up with something with a little more research just to have something, one selection of light, but we don't have those taps on the transformer anymore. So then it's be hard pressed to find an exact duplicate. But I don't know, we may just go with that. Use the sleep timer radio. Maybe disconnect some of the secondaries and just have the light operate, but just have it at one setting.